Good morning to all of you. So today also I'll be teaching the chemistry, chapter number 7, P block elements, the inorganic part. So last year in the previous class, that is in class 7, you learned about group number 1, that is alkali metals, and alkali are metals. So which you have already learned, group number 1 and group number 2. So that is S block elements. But today you will be learning the P block elements. So in this P block elements, I'll be teaching you how to make the, first of all, to make the periodic table according to the atomic number and its size configuration. So let me start how to make the periodic table of P block elements. As we know, P block elements is located or situated on the right side of the periodic table chart. So I'm going to make in a very simple way, so which you don't have to memorize also. There is a certain way to learn the P block elements, but I'm going to tell you the easy tips to learn the periodic table. So I will start from group number 13, 14, then 15, then 16, then 17, then 18. So as we know, the P block elements, the group belonging from 13 to 18 are known as P block elements, and its configuration is NS2 NP1 to 6. So again I'm going to repeat. The P block element is always located on the right side of the modern periodic table chart. The meaning of P block element means the group belonging from 13 to 18 are known as P block elements. So, and its configuration is, as I have written in the board, NS2 NP1 to 6. So today we will be learning the atomic size of P block elements, atomic radii, ionization, enthalpy, configuration, and the reaction. So I will start from 13. What elements are there according to the atomic number and atomic mass number and atomic size? So in group number 13, we have boron, we have aluminium, we have gallium, we have indium, then we have thallium. So in 14, we have carbon, we have silicon, then we have germanium, then tin, then lead. So you can, doesn't mean that you have to memorize as I have written, but you can do in a simple method, as I told before also, like brother, for group number 13, brother Andrew got intelligent thought. So I have written in a simple way how to memorize, how to learn the elements which is located in group number 13. So brother Andrew got intelligent thought. So B indicates for boron, A indicates for aluminium, G indicates for gallium, I indicates for indium, T indicates for thallium. So now I like to go for a group number 14. For group number 14, I will write over here, I will write down the group number 13. So for the 14, we can learn, can sun go to left? So in that way you can learn the easy method. So can means carbon, S means silicon, go means germanium, 2 means tin, L, that is left, means Pb. So now group number 15, which is one of the most important one, So in group number 15 we have nitrogen, we have phosphorus, we have arsenic, we have antimony, we have bismuth. So as we know, group number 13 family is a boron family. I am writing on top of the number boron. 14 is carbon family. Then 15 is, we have two names, nitrogen, nitrogen, or we can say nitrogen. So now group number 13 and 14 I will just give it because you have learning class level. So from here I am going to start each configuration, how to write the configuration of group number 15. So I will write the 13 and 14, how to write its electronic configuration with SPD blocks. So as we know, boron atomic number, nitrogen atomic number is, over here boron is, nitrogen atomic number is 7, phosphorus is 15. So how to write the electronic configuration? So nitrogen, I will start with a nitrogen. So nitrogen, how to write the electronic configuration in SPD blocks? 1s2, 2s2, then 2p3. Because the outermost cell of group 15 is 5. So again I am repeating, the outermost cell of group number 15 is 5. So this is the electronic configuration of nitrogen, N1s2, 2s2, 2p3. So again I will show you P, that is group number 15 only, phosphorus, then 1s2, 2s2, 2p6, 3s2, so 2 plus 2 is 4, 4 plus 6 is 10, then 12, 3p3. So in that way you can learn the group number 15. Now in the group number 15 we have certain structure is here and chemical reaction is here. So that also I am going to teach you in the board itself only. Now this nitrogen or group number 15 can be bond with any elements, mostly with hydrogen. So nitrogen, as I told you, it can be bonded mostly with hydrogen. So NH3. So how to make the structure, the dot structure, and as well as structural diagram. So nitrogen, so we have 3 hydrogen, 1H, 1H, 1H. First of all, I am showing now how to make the dot structure of nitrogen. As we know, the outermost cell of nitrogen is 5. So we can share each electrons to hydrogen 1, 1. So from hydrogen 1, from hydrogen 1, from hydrogen 1. So it is bonding. So now the remaining one we can write over here, which is a lone pair. This is a lone pair, lone pair. So similarly, phosphorus also will be same as it is, like pH3. Okay. Then phosphorus, as we know, the atomic number of phosphorus is 15. Okay, and its outermost cell is 5. So hydrogen 1H, 1H, 1H. So phosphorus outermost cell is 5. 1 here, 1 here, 1 here. So we are sharing the electrons from hydrogen 1, from hydrogen 1, from hydrogen 1. So the remaining is 2. So this becomes a lone pair. Oh. Now directly we will go to group number 16. As we know, group number 15 is nitrogens or nitrogen. Group number 16 is halogens, CHALOGENS, halogens. So over in these 16 elements, what elements are there? That also I'm going to write. So we have oxygen, sulfur, selenium, then we have tellurium, then we have polonium. So over here also the reactivity and the configuration of halogens family will be, since the outermost cell of group number 16 is 2, so suppose as the reaction I'm going to show you. In group number 16 we have oxygen, we have sulfur, selenium, tellurium and polonium. Now same as it is, I'm going to show you the electronic configuration of group number 16, oxygen. The atomic number of oxygen is 8. Then how to write the electronic configuration as it is like group 15, 1s2, 2s2, 2p4. As I told you, the outermost cell of halogen is 4. Then sulfur. Atomic number is 16. So 1s2, 2s2, 2p6. Then 2p, 3s2, then 3p. So to make it 16, over here 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 2 is 12, then 4. So group number 16, outermost electronic configuration I have written on the board. Now group number 17, as we know, group number 17 is a very simple one which very commonly we bonded with organic part, that is a halogen. I'm writing over here halogen, halogen. Then we can write fluorine, chlorine, bromine, iodine or Si. So it's a group number 17, and as it is the electronic configuration, the outermost cell of, since the fluorine outermost cell is atomic number is 9, so that also I'm going to prove. 1s2, 2s2, 2p6, 2p6, 2 plus 2 is 4, 4 plus 6 is 10, 3s1. So in that way you will get the electronic configuration of, sorry for that. So fluorine 1s2, 2s2, since the atomic number is 9, then 2p, so 4 plus 5. So in that way we will learn how to make the configuration of group number 17. Now let me go directly how to make the structure of these groups. Again, I'm going to start from group number 15. As we know, occurrence of nitrogen. So nitrogen was discovered by Daniel Rutherford in the year 1772. Now nitrogen, how to make the structure of nitrogen is a very simple. Suppose N2, so N here, 1N, 2N, I mean 1, 2, 6. Since the atomic number of nitrogen is 5, 7, I mean 7 I will write down on the side, out of 7, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Let's come back to the group number 16 again. So in group number 16, we have oxygen, we have sulfur, we have selenium, we have tellurium, we have polonium. So as I have written, now we will go for the electronic configuration, the one of the most important one. So how to make the electronic configuration of group number 16? So I will show in the board. As we know, the atomic number of oxygen is 8. Out of 8, let's find out, or let's learn how to write the electronic configuration of group number 16, that is oxygen, at 1s2, 2s2, 2p4. Now let's go for the sulfur. Sulfur atomic number is 16, 16 1s2, 2s2, 2p6, that is 2 plus 2 is 4, 4 plus 6 is 10, then 3s2, then 3p4. So here you can see the similarity. So p4. So it means the outermost cell of 16 is 4. Now let's go to the 17. 17 we have what elements are there as I have written in the board. We have fluorine, we have chlorine, we have bromine, we have iodine. These elements are very common, which are bonded mostly with organic compounds. So fluorine, as we know, let me go to the electronic configuration. Fluorine, atomic number is 9, 1s2, 2s2, then 2p, 2 plus 2 is 4, to become a 9 we require 5. So 1 half so on. Now chlorine. Chlorine atomic number is 17, then 17, 1s2, 2s2, 2p. Then 17 means 2p 6, then 3s2, then 3p4. 3p, I mean 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 2 is 12, to become a 17 we require 5. So the similarity 2p5, 3p5. So in that way we can learn the elements group number 17. Now let me go the bone and its dot structure. Let me go to the group number 15. That is, the family name is Nicosin. Now I am going to tell you how to make the dot structure. So in this dot structure of each elements I am going to show you in the board itself. First of all, let's learn about nitrogen. Nitrogen was, as we know, nitrogen was discovered by Daniel Rutherford in the year 1772. So nitrogen occur in free state. Nitrogen occur in free state which contain 78% in our earth crust. So we will not go that much in detail. Now directly I will go to the dot structure. How to make the dot structure of nitrogen. And since the nitrogen atomic number is 7. So 7 we have to segregate. It is 2 in K cell and 5. So N2. So 1 N here, 1 N here. Now the outermost cell is 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this becomes lone pair. So bonding we can write. So the structure of nitrogen become. That's the dot structure of nitrogen. So similarly, I would like to show you. I like to show you phosphorus 2 also. As we know, the atomic number of phosphorus is 15. 15. How to learn how to make the dot structure of phosphorus, that is 15. Let's segregate 2 in K cell, 8 and 5. So P2, so P1 here, P1 here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This to become lone pair. So the structure of phosphorus is with 2 lone pair. So it's quite similar with nitrogen. Now let's go to the oxygen, the dot structure of oxygen. As we know, oxygen atomic number is 8. Let's segregate in case KLMN. 2 here, 6. So the outermost cell is 6. O2, 1, 1. So 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the dot structure of oxygen becomes 1, 2, 1, 2, 3 pair. So we have 2 lone pair. 1, 2, 3, 4. So this is the dot structure of. Let's directly start the preparation part. As we know, nitrogen occurs in free state in nature, which usually contains of 78% of nitrogen by volume. Now let's go the preparation of dinitrogen. So dinitrogen preparation. In the dinitrogen preparation, we'll go chemical reaction with chemical reaction. First of all, dinitrogen can be prepared on heating to decompose ammonium nitrate. So I will write the chemical reaction over here. NH4, that is ammonium nitrite. NH4 is ammonium, NO2 is nitrite. Then this delta indicates heating effect. Then N2, 2H2O. We have already decomposed and we have already balanced. See, 1, 2, N is 2, N2 already balanced on the product part. H is 4, 2 into 2 is 4, O is 2, 2O. Secondly, since ammonium nitride is very unstable, it can be kept as such, hence dinitrogen is usually prepared by heating a mixture of ammonium chloride or N as well as sodium NaNO2 nitride. So NaNO2 means sodium nitride. So I will show the reaction. This is the first reaction. Now second reaction by ammonium chloride and sodium nitride. NH4, that is ammonium, NH4Cl plus NaNO2 sodium nitride. So we have to write the delta because it's a heating. So we have to heat. Now I will balance NH4, then NO2. We have to, in the product part, we have to decompose ammonium nitride, then NaCl, sodium chloride, we will decompose. So then secondly, that's the preparation of dinitrogen. Second, we have finished. Now let's go directly to the third preparation. In the third preparation, this ammonium nitride or sodium nitride, which we have balanced through decomposition. Now dinitrogen can be prepared by ammonium dichromate. The formula is NH4 to Cr2O7. That we have to decompose on heating. So we will put delta, that is for heating, and 4 plus 4H2O plus Cr2O3. Now I will prove how it balances. Since over here nitrogen is 2, hydrogen is 4 over here. 4 into 2 is hydrogen is 8. Then chromium Cr, that is 2. Then O is 7. Now in the product part, since N is 2 and 2 already balanced, I'm taking mark. So H is 4, 2 into 2 is 4. Now O is 4. O is over here in the reactant is 7. Now O is 4. Now Cr is 2, already balanced. Now O is 7 in the reactant. Now we have to balance in the product also. O is 4, 4 plus 3. Here 3. Look over here, this is 3. And look over here 4. So as we know, 4 plus 3 is 7. So we have balanced the ammonium dichromate. Now directly we will go the preparation of ammonia. As we know, ammonia gas is usually prepared in the laboratory by gently heating with ammonium chloride, that is the formula NH4 ammonium chloride, NH4Cl plus we can write calcium hydroxide, which we commonly known as caustic soda, we can say. Now how to balance it? So 2NH4, the preparation part, Cl plus Ca calcium hydroxide, that is caustic soda. Now this delta indicates the heating. So how to decompose? CaCl2 plus 2NH4OH plus 2NH3 plus 2H2. So I will again show you. As a repetition, ammonia gas is usually prepared in the laboratory by gently heating ammonium chloride and calcium hydroxide, which we commonly known as caustic soda. So now the chemical reaction, I'll show you. 2NH4Cl plus calcium hydroxide CaOH2. So that we have to decompose. That is delta indicates heating. Then CaCl2 plus 2NH4OH plus 2NH3, it is ammonia, 2H2O. So in that way we're getting the chemical reaction. Now I'm going to prove how it's balanced. So I'll wrap this part too. So let's start with what elements are there. Nitrogen is there, hydrogen is there, chlorine is there, calcium is there, oxygen is there, hydrogen is there. So NH, chlorine, calcium, then oxygen. So in nitrogen, how many atoms are there? You can see 2. I will write here on the reactant part 2. Then hydrogen 4. 4 into 2 is 4 into 2 is 8. 4 into 2 is 8. 8 plus again 2 is 10. Then the hydrogen is already 10 on the reactant part. Now let's go for chlorine. Chlorine is 2 over here. 2. Then calcium is also 1 only. Then oxygen. Let's come to the oxygen. Oxygen is 2 over here. 2. So in the reactant part, since this delta indicates heating, so calcium is 1, calcium 1, only 1 balance. I'm writing on top. So chlorine is chloride. Chloride is 2, chloride 2 balance. Okay, this is on the number of atoms present on the reactant, as I have written on the red marker. Now let's go for the nitrogen. Since the nitrogen is 2, nitrogen is 2. Over here we have written 2 nitrogen. Nitrogen 2. Then we have hydrogen. Hydrogen we have 10. Now here 4. 4 plus 2 is 6. 6 plus again 4 is 10. 10 plus 2. So now let's go straight to the preparation of ammonia. As we know, the formula of ammonia is NH3. So as we know, ammonia gas is usually prepared in the laboratory by gently heating ammonium chloride, it is NH4Cl, plus calcium chloride, CaOH2, which generally we known as caustic soda. Now I would like to write the preparation of ammonia. Preparation of ammonia, NH3. So as I told you, ammonia gas is usually prepared in the laboratory. So over here I will only show the chemical reaction. I will take 2 NH4Cl, ammonium chloride, plus calcium hydroxide, then decomposes CaCl2 calcium chloride, 2 NH4OH plus 2 NH3 plus 2 H2. So in that way we are getting calcium chloride in the preparation when it reacts with ammonium chloride reacting with caustic soda. It is calcium hydroxide, calcium chloride, ammonium hydroxide, ammonia and water. That's all for